Let's look at another word problem about permutations. So Greg, Nami, Deanna, and Jacob want to take a group picture, but they keep arguing about who should stand next to whom and who should be on the end. How many different ways can the four of them order themselves in a line of four to take the picture? Okay, so again, we want to see whether this is a permutation or a combination. Now, the title at the top of the video should probably be a hint, but another hint is that they keep arguing about who should stand next to whom and who should be on the end. And we want to see the ways that the four of them can order themselves in a line of four to take the picture. So that tells us that order matters. So that means that this is a permutation question. Another question that we want to ask ourselves now is repetition allowed? So, for instance, with our bike lock combination, it was possible for us to have the order 0, 0, 0, 0. So we could repeat the digit as many times as we wanted. But I think for this picture, it's going to be impossible for Greg to stand next to Greg, and then have Greg, and then have Greg. So it looks like to me that repetition is not allowed. Okay, so how can we approach this problem? We're going to look at this a little bit like we did the last time. So just consider the four spaces that we have available. So we're going to put one person in each of these spaces. Now, how many options do we have for the first space? So let's see. The first one could really be any of them. It could be Greg, Nami, Deanna, or Jacob. So we have 4 options for the first space. But then once that first space is filled, how many options do we have for the next one? I'm going to take a moment to pause the video and see if you can figure out on your own how many options we have for the next person. Okay, so once we have the first space filled, we then only have 3 options for the next person because we can't repeat the person who's in the first space. So let's see, if for the second space we can have 3 different people fill it. But then again, when we want to fill the third space, we can't repeat the person who's in the first space or the second space, so we have only 2 options. And then once those first 3 spaces are filled, then we have 1 option for the last one. So it looks like the number of options that we have is 4 times 3 times 2 times 1. So let's see, 4 times 3 is 12. Times 2 times 1, and that's going to be the same as 24 times 1, which is 24. So it looks like there are 24 different ways that they can order themselves. Now let's take a look back at what we did. So we figured out that this is a permutation and that repetition was not allowed. So what we ended up doing was taking the number of options that we had, then multiplying it by 1 less than that, and then by 1 less than that, and then by 1 less than that, until all of our spaces were filled. So there's a special name for what happens when you take, say, 4 times 3 times 2 times 1, or if you took 5 times 4 times 3 times 2 times 1. So if you take a number and multiply it then by all of the numbers less than it until you get to 1, that's called a factorial. So, and the symbol that we use to denote factorial is an exclamation point. So 4 times 3 times 2 times 1 is the same as 4 exclamation point. And so 5 times 4 times 3 times 2 times 1 is 5 factorial. So that's an important thing to remember when you're working with permutations. Sometimes you can use a factorial to make your calculations a little bit easier.